Praise the Lord. His word in James 1:6 says, but let him ask in faith with no doubting. For he who doubts is like a wave of the sea, driven and tossed by the wind. So when you go before God in prayer, keep your faith, don't doubt, and God will answer your prayers. I'm Teacher Alton from the Math Ministry, and today we're going to get some insights into your functions questions on your CSEC and Math 2017 past paper. So we're going to begin with question number 9. So let's go to question number 9. So this question gives us functions f and g. So function f and g are defined as follows. X plus 1 divided by x minus 1, and function g as 2x plus 1. So we are asked to find what is the composite function f g of x. Okay, so what this means really is that you are substituting in place of x in your f of x function the entire g of x function. So let's see what that becomes. Substitute in place of x in your f of x function the entire g of x function. So this becomes 2x plus 1 plus 1 divided by 2x plus 1 minus 1. So let's further simplify this. This is 2x plus 1 over 2x plus 1 minus 1. I'm saying minus 1 and I'm writing minus x. So you see how the hand can play tricks on you, eh? Right, let's go again. Plus 1 minus 1. Okay, so this becomes 2x plus 2 divided by 2x. Right, and this can further be simplified. 2 can be factored out, x plus 1 all over 2x. So our final answer seems to be x plus 1 divided by x. Now let's double check that. It always a good idea to quickly double check your working. Substituting g of x, 2x plus 1, in place of x into the f of x function. So it goes here and it goes here. 2x plus 1 over 2x plus 1 minus 1. Simplify. That becomes 2x plus 2. Denominator becomes 2x. Further factorize 2 into x plus 1 over 2x. 2 can cancel out, giving us x plus 1 over x. Right, and of course, your answer is A. Now it says, just to appreciate what is stated here, it says that in A, x cannot be 0 because division by 0 is not possible. This x cannot take on a value of 0, and x is just part of the real number system, right? Okay, so moving on to question number 10. Right, so you're given a function m. Let's see how it's expressed. X is mapped onto 5 plus 2x. Right, now we know that this could be written as m of x equals to 5 plus 2x. So it's just two different ways of saying the same thing, really. Right, so this is important because the question asks us to find m of 4 minus 2a. So it means that where you see x, you are substituting 4 minus 2a. So it becomes 5 plus 2, open brackets, 4 minus 2a, close brackets. Expand and simplify. 5 plus 8 minus 4a, giving us 13 minus 4a. So let's see which one corresponds to that. That's answer D. Right, let's continue our journey into solving these functions question. Right, so number 11 is our final question on functions in our 2017 past paper. Right, so your inverse function f of x is such that x is mapped onto x minus 1, x squared minus 1. And it tells us x is greater than or equal to 0. Now, I want us to do a quick recap so we'll see how it works. Before we solve this problem, let's see how it works. If you are given a function f of x, and let's say this is 2x plus 3, and you're asked to find f inverse. So the background noise you may be hearing is that of rain falling. I hope you can still hear me clearly. Now let's see how the working actually goes. Now usually we say let y represent f inverse. So we'll say f of y equals to x. So we will now substitute from line 1, we'll now substitute y into that function. So it becomes 2y plus 3 equals to x. And we solve for y. So this becomes 2y equals to x minus 3. Y equals to x minus 3 upon 2. And y is our f inverse because we defined it earlier right here. So we can conclude that's x minus 3 over 2 is our f inverse. Now, the question is starting at the end right here with the f inverse expression, and we need to work back to determine what is the function up here. Right, so let's see how that is done. Right, so we got to pray for the wisdom of God in this one. Right, so this is where we are, class. We given f inverse x equals to x squared minus 1. So we are here. Let's look at the line before. We had a y, right, equals to x squared minus 1, right here. Then, of course, let's work all the way back. So we need to solve for x here, right here. We need to solve for x. So if we're solving for x, we'll have y plus 1 equals to x squared. So let's take the square root now. The square root of y plus 1 is equal to x. So what does that tell us? When we reach here, let's compare it with what we have up here, and you'll notice it is really the same thing for our f of x function. The only difference is the x and the y are interchange. You see that? So 2x plus 3, we have 2y plus 3 equal to x. The x and the y are interchange. So let's do that. So we have the square root of x plus 1 equals to y. And of course, y is what we know as our f of x. Right. And that is the function that should be our answer. F of x is the square root of x plus 1. Right. And that answer corresponds to B. It's written like this. The function f is such that x maps onto the square root, and they did use brackets here, x plus 1. That's a lot of rain, isn't it? That's the blessings of God showering upon us. And of course, x must be greater than or equal to minus 1, or else division, the square root of a negative number will not be possible. Right, let's go over this for those who may still be wondering what just went on here. Let's take it from the top. I use an example here just to look at the process of solving or finding your f inverse. So I use an example. If f of x is 2x plus 3, to find your f inverse, you would start off by letting y equal to f inverse x. F of y is x. You substitute y directly here. You get 2y plus 3 equals to x, and then you solve for y. Since we define y as the inverse of f of x, then f inverse x will be x minus 3 over 2. Now the question starts at the bottom here. It starts with the inverse function, and we need to determine what is the original f of x function. So we need to work backwards kind of way, and that is what we attempted to do here. If you look at the last line, we start off with the f inverse function, which is given as x squared minus 1. Here it is. The line before is where we interchange. Now, we replace y as our f inverse. That's what we did here. Because it was defined, y was defined as f inverse x right here. So we can't do that. And then we solve a couple steps that working backwards, took us to a place where we had x as the subject. In other words, we're solving for x. And that's what we're doing here. When we solve for x, we take the minus 1 across plus 1. All right, the sellers don't tell students that. What we're supposed to say is you add 1 on both sides. Minus 1 plus 1. And of course, this will cancel out. So it will be y plus 1 equals to x squared. And then to make x the subject, you take the square root y plus 1. And that'll be x. Nice. Now, what we saw here at this point, to find our f of x function, it resembles the f of x function, 2x plus 3. The only difference is our x and y need to be interchanged or replaced by one with the other. So we need to replace y with x and x with y. That's what we did right here. And of course, we know y is really our f of x. So that's how we end up with our final line here. And this is just another way of saying the same thing which is stated right here. The f function is such that x is mapped onto square root of x plus 1. This restriction simply means that if you put anything less than minus 1 into this, it becomes a negative value and the square root is not possible. So the restriction must be placed on your values of x. Okay, that was a way to end number 11. So that takes us to the end of our functions, and may God continue to bless you. Bye.